Hi everyone. Welcome to day one of Generative AI in Action, Practical Skills for Real-World Applications. My name is Heather Shoenberger. I'm an Associate Professor of Advertising at the Bellisario College of Communications, and I'm going to be your guide on this journey over the next 3 weeks, where hopefully you'll get an idea of what the technology is and how to use it in your daily lives. So, artificial intelligence has been the dream of humanity to create for many years. So basically, humans have wanted to create an intelligence that is similar to our own, if not identical. And as a result, we're trying to develop computers with the ability to reason, discover meaning, and generalize. And so we're getting a little closer to that. Of course, we're not at artificial general intelligence yet. We're still at the artificial generative intelligence stage, which is vastly different. And that's what I'm going to be talking about today. But as I noted, this has been an ongoing pursuit. And so every once in a while, there'd be a really big advancement, and AI would be a big topic. And then there would be a winter where something would slow it down. Maybe there wasn't enough data. Maybe there wasn't enough computational power. Maybe there wasn't enough algorithmic sophistication. So that happened a couple of times. I'm just going to highlight some of the background. So John von Neumann created the architecture for modern computers. Then Turing formalized digital computing. Pitts, who was a homeless kid from Detroit, ended up working with Professor McCullough, and they came up with the idea of neurons in a computational sense, but they didn't have a way to really actualize their ideas. So it was just theoretical at that point. And then Rosenblatt came up with the idea of the algorithm to train the Pitts and McCullough model. And so then we start to see some pretty significant changes. So how far have we come? As you can see on this image, there are numbers in the top left corner, 4627. In 1989, we have the first convolutional network, and this was allowing the post office essentially to recognize handwritten numbers so that it could get your mail to the right place. Then if you look to the image below, for a while the computers had a really hard time distinguishing between a blueberry muffin and a dog face. So they looked very similar, and it was hard to distinguish. We have early ChatGPT struggling with this particular problem. The problem was, I have a book, 9 eggs, a laptop, a bottle, and a nail. Please tell me how to stack them onto each other in a stable manner. This is kind of a tricky question. And the old ChatGPT from a couple years ago said, finally, place the eggs on top of the nail, making sure they're balanced and not tilting to one side, which obviously was not going to work. But now if you ask the same question in 2024, it gives you an answer that's a lot more feasible. So I arranged the 9 eggs in a 3x3 square on top of the book, ... So we've come a long way with being able to recognize images, recognize numbers and text. So large language models, these are what the hype is all about. ChatGPT, Gemini, DeepSeek, etc. All they're doing, literally all they're doing is predicting the next word or token based on the sequences of words that came before it. So here's how it works in stages. So you have input. So let's say you start with a sentence, the cat is on the, and there's a space, like there's no answer yet. The prediction, so the model is going to predict based on probabilities what the next word might be. Then it selects that word. So in this case, the model is going to pick the word with the highest probability, and sometimes it can randomly sample from a set of high probability choices. So let's imagine high probability choices are mat, roof, chair. So the cat is on the mat, roof, or chair. All of those could be high probability choices, and there is some randomness in that selection. That little piece is really interesting because as we'll get to in later sessions, the output of these large language models is always slightly different. And that's in part based on the selection process. And then repeat. So once the word is selected, it updates the context and uses the new sequence. So example, the cat is on the mat, and now it's going to predict the next word. And so it continues to predict, and we get we end up with the paragraphs or photos that we see today. So how did this happen and why is it happening now? So as I mentioned before, there were advancements in artificial intelligence and then it would stop. And then there would be a little bit of a flurry of advancement and then it would stop again. The reason that we're at this stage right now with the capabilities of generative AI are because of three main pillars. The first is computation. We have more compute power now, so we're able to run the computations. We're able to store that data. Algorithms have really become more sophisticated and a lot better. And then data. We have just a plethora of data, which we didn't have before. And data is key. So what's important here to keep in mind is that data never sleeps. So every time you're logging into your phone, you're sending an email, you're commenting on an Instagram post, you're looking at Instagram, all of this information is being captured, saved, and stored. And in fact, it's such a large and energy-consuming process that in order to keep the data centers cool, companies like Microsoft and Meta are actually sinking them in the ocean and putting them in cold places to make sure the data centers don't overheat while they're collecting all of the data that we create. Algorithms have become increasingly sophisticated. In fact, this year's Nobel Prize in Physics went to computer scientists, John Hopfield and Geoffrey Hinton, for their efficient optimization methods, which led us to where we are today with generative AI. And computational power has increased significantly. Just to give you kind of an idea, these are little chips. It used to be, like, I remember when I was a child, we went and visited a computer at Syracuse University, and I think it was doing just a simple task, but it was literally a whole room full of computer. Now we're able to put a lot of information on a tiny little chip, but it still takes up quite a bit of space. But also, another part of that equation is that it's tremendously expensive to buy the chips and then train the models. Just to give you an idea, some of the training costs, ChatGPT 4 costs $78.4 million to train. Gemini Ultra was $191.4 million to train. So this also sort of edges out smaller companies from training these models and leaves the power of training in the company's hands who have the money to do so. So the impact of AI is, we're not entirely sure yet, but there are a lot of predictions. One of them is that there's a 13 trillion AI value creation by 2030. There's a lot of value created by AI will be outside the software industry, which is the one being hit the hardest. Incidentally, I'll talk about that in a second. But AI is planning, we suspect it will have a huge impact on all major industries. So in that vein, why do we think that's happening? So the general, so you probably heard of ChatGPT. So another GPT that you should be aware of is the idea of general purpose technologies. And these are just technological advancements that have infiltrated our everyday lives. They've changed the way we live. They've changed our societal fabric. They've changed industry. And this isn't the first time that we've lived through, or humanity has lived through changes like this. Some of the key characteristics of GPTs are that they're pervasive. They spread to many sectors. They are going to improve over time, so they're getting better and more efficient. They create innovation, so they enable the creation of lots of new products and processes. And some examples from the past are steam power, which we still feel the effects of today. Electricity, obviously, I wouldn't be sitting in this studio without electricity. Neither would I without the computer or the internet. Generative AI has at least the potential to be considered here. Blockchain is status a little bit more debated, but these GPTs become entwined in our existence, as I mentioned before. And this is just an interesting stat that is, of course, we can't prove it at this point. It's just a projection. But steam power increased worker productivity by about 20% overall. Generative AI is suspected to produce 20 to 80% improvement in productivity, which is significantly more. We saw steam power or the Industrial Revolution changing the way we live. People migrated to cities. Our lives became dictated by clocks. Newspapers and advertising began to flourish. Generative AI, too, may have huge impacts on our society. Everything from misinformation being hard to control, to AI tutors, to the ability to create stories, images, and changing the landscape of creative fields, and many others. And one thing that is really interesting about this technology as well is that it's different from previous general purpose technology revolutions in that there's been a rapid adoption. ChatGPT had 100 million users in its first week after launch. So people are using it all the time, these technologies, and it's improving rapidly. I'll give you some examples of that in a second, but just to highlight that ChatGPT 3.5, which was the model just released a couple of years ago, at first on the Uniform Bar Exam, which is what lawyers take, I actually took that exam, and it scored in the 10th percentile. The new model scored in the 90th percentile, just to give you an idea of how dramatic the improvements are, even within a year or two, sometimes even within a week. So there's a lot of good with AI. So there's a lot of hope that this is going to be a technology that improves our lives. And that's probably why you tuned in to this webinar, because you're hoping it's going to, in fact, make your lives a little bit more efficient, or maybe you're just curious. But the AlphaFold was a really long-standing problem. And what we were able to do, what we had is data. So NIH researchers and NSF researchers were uploading their data to a database for years. And once we had this model that we were able to train, they were able to solve the problem that we've been working on for 50 years. And that discovery won a Nobel Prize, the Chemistry Nobel Prize. So interesting, both physics and the Chemistry Nobel Prize went to computer scientists, which is really telling of how far-reaching and integrative this technology is and will be in our lives. Another good is the very strong reasoning that these models are beginning to show. And the alpha proof was able to win one of these science or mathematics Olympiad problems, or solve a science Olympiad problem. One thing I will note is that there's still a lot of difference between human intelligence and computer intelligence, which we'll talk about in a minute. But just to highlight that, alpha proof took 3 days to reason through the proof, where the best of the best mathematicians who were human take about 1.5 hours to get to the same answer. Of course, there's also bads, and we'll talk about this again in the rest of this lecture, but we're constantly thinking about whether we should reject or embrace this technology, and this particular technology comes with a lot of caveats that we need to be careful of. If you see the highlighted portion of this academic paper, it was clearly a paper written by ChatGPT, and it was published. So, I mean, there's issues of quality control there, obviously, but also issues of plagiarism or just ethics issues at the very highest level. So forget about our students cheating. Like, professors and scientists are cheating too. Another thing that we have to be really cognizant of is that using this technology could really take a hit at our ability to think critically. And that's something that we talk about with our students quite a bit in the generative AI course that I co-teach. Just that critical thinking is going to be key. And if you're working with this technology, you really have to have that in mind. Like, you can't just rely on it to come up with answers for you. You need to really think carefully about why the answer is correct. Is it correct for your particular purpose? Etc. But there are researchers that are concerned that it's going to make us dumb. Also, some sad things have happened. So, in Korea, there was a man crushed to death by a robot. It mistook him for a box. And there was a teenager who had an unfortunate a suicide that was attributed to a relationship that was built with a chatbot. All of these things are things that we have to keep in mind. But I want to leave this particular section with a cautionary note about whether or not we should reject or embrace, just based on a historical story. So the Ottoman Empire was doing very well when the printing press was first introduced. But they were concerned that people would be losing jobs if they had the printing press. They were concerned that fake copies of the Quran would be distributed and that a lot of fake news would be disseminated. As a result, they passed on adopting the printing press and said, let's wait and see how other societies handle this, and then we'll integrate it into ours once we see what has happened in other societies. And of course, by the time they did that, they were way behind. So that's just a cautionary tale as whether or not we should reject or embrace as you're thinking about that. So here's an outline for the rest of the course. So I wanted to note that this is going to be a lecture that is just essentially lecture based. I'm going to go over the idea of AI, what it is, the blessings, curses, and what it means to live with artificial intelligence. Lectures 2 and 3 are going to be more practical, sort of hands-on. And so you'll be following along with exercises and learning how to use the technology. And I'll be only using the free, accessible options, so you don't have to worry about paying for any technology that we're going to be using in this seminar. So, what is generative AI? So first of all, it's good to kind of think about where it falls in place with this whole idea of artificial intelligence. So I started off this lecture telling you that the dream of humans for many years has been to create essentially their own image, a computer that can think, believe, behave, predict, reason, make decisions a lot like or identical to a human. That's this whole philosophical idea of artificial intelligence. Robotics, everything is included under that umbrella. And we're not there for a lot of the general purpose or the general artificial intelligence. Machine learning is a subset of artificial intelligence. Then you'll see neural networks, a smaller subset. And at the very bottom here, under deep learning, you'll see generative AI. So I think it's important to remember generative AI is just one small subset of what artificial intelligence is. And so that's what we're going to be focusing on today. So we're dealing with data-driven problem solving. So remember, without the data, we could not be doing what we're doing now. We needed the data to be able to train our algorithms and then to be able to have the outputs that we'll be talking about in later lessons. Machine learning is a data-driven problem-solving tool. It has two capabilities currently. One is to predict. So in this case, we're trying to extract patterns to predict something in the future. In generative, we're learning patterns from existing data and generating new content. So that's generative AI. That's the purview of large language models like ChatGPT and Gemini. So here's a good example just to sort of get your mind starting to think about how this works. So self-driving cars, they're a thing. But let's imagine that we want a human to code all of the potential possibilities for what might happen while you're driving. There's no recipe for driving. There's not like a cookbook you can give to your 16 or 15-year-old and say, learn this and you will be a driving expert. That is not the reality. There's a lot of things that are dynamic, a lot of things that are happening, new situations, road conditions, etc. Surprise things like a pedestrian walks out in the middle of the road or a cat, runs out in front of you. All of these things are really challenging to code because the myriad of experience driving is just gigantic. It would take forever for someone to code every single possibility, and it would be hard to imagine that that could even be coded by a human. It's super tedious, and it's unlikely that a human would be able to get every single piece. So what we do is we mount cameras and sensors and log examples of good driving behavior. And we feed it into an algorithm. And we say, algorithm, figure this out for us. Instead of the human coding everything, the algorithm learns from the data that we've given it. And what it does is it outputs a computer program that can then help you to drive the car. It's not perfect. There's still error, but it's a lot faster, and it's a lot more scalable. Okay. So this is another example to give you an idea of how these models work. So Johann Kepler was a German astronomer and mathematician. He's best known for the laws of planetary motion, which really revolutionized how we understand the solar system. He was working with Brahe, who observed that the planets. What Brahe did was he made observation, and he was meticulous and had tons of data about all of the positioning of the planets, all of the data you could possibly imagine. He amassed over his lifetime. And when he died, Kepler worked tirelessly to determine the laws that governed all of the data that Brahe had collected, and distilled knowledge from that, which has now led us to what we have later called Newtonian physics. So basically, he worked tirelessly to find the patterns in this data and create laws from it, which we consider knowledge. And since then, we've been attempting to model knowledge, just mathematical way to understand how we create knowledge. So another practical example that I think is helpful is thinking about spiders and spider webs. So spiders don't have a very good memory. Hopefully an entomologist on here isn't shaking their head about that. But there is a technique that spiders will use to make it more likely that they'll be able to catch their prey. So what they do is when their prey hits the web and they find it, they reinforce that piece of the web. So they're turning that data about where that particular creature or prey hit, and they're turning it into knowledge, which is expressed in the thickness of the web. So the next time prey hits the web in that same spot, it vibrates a little louder, and the spider is able to reinforce the web in the most likely places for prey to hit. And so that's just an example of expressing knowledge with the thickness of the web. So computer scientists have envisioned computers working very similarly to how our brain functions. And that is an interesting topic for another day probably, but basically it's modeled on the idea that our brains are powered by neurons, and that neurons, as we learn, so when you're a baby, you basically start with very low weights on most neurons. Once you start to understand a certain voice or certain stimuli, maybe something is hot, then weights become added to these neurons, and that becomes your knowledge. Now I know that if I, touch this particular surface, it's going to be hot. So that weight is stronger than maybe a more neutral surface that isn't. That's a really basic way of explaining this, but that leads us to the mathematical model of a neuron. So we're trying to model knowledge. We're similarly, we're doing this mathematically, but it's a similar mechanism that was being done with the spider. What we're doing is we have inputs, they're mathematical inputs, and we weight them based on their importance. So if we're imagining that each of these input layers, or the x1, x2, is a word, so maybe we're going to weight based on the probability that word is used more in language. This is just a very basic example. But weights are applied to each of these inputs, and then it will help to lead us to the output. So knowledge in the brain and so this is basically what we're calling deep learning. So as babies read, and those books are very silly, they always start with, this is a ball. And then it explains like nuclear physics or whatever to babies. But your brain, assigns weights and it starts to learn. Reading books, interacting with other people, interacting with the environment, etc. That is exactly how these models are trained too, on the premise that we're trying to train them, trying to build them in the same way that we believe the brain works. So basically, this is the pipeline. This is what machine learning does. You have data, bunch of data. We input it to a model. The model optimizes that data. So the model is, when it's training, it's applying weights. So it's saying like, this is a dangerous car, this is a not dangerous car, for example, and then it makes its prediction. So what we have here is the difference sort of between just visually predictive and generative AI. So I mentioned before that machine learning is working in both predictive and generative. Obviously, the large language models are generative models. So we're going from a human prompt, so something that I'm writing a text prompt. The model is is trained to understand what that prompt is and then provide or generate a new response. So how does this work? This is actually really cool. So imagine you have just a normal Gaussian curve, and that we have training data that follow that curve. So if we have the training data, and if we're able to, from that data, derive some variance, a standard deviation, a mean, then we can make predictions from that data, or we can make and generate new data points from that data. But what we need in a Gaussian distribution is the important pieces, which are mean and variance. If we don't have that, we can't make predictions because there's no meaning to the data distribution. So that leads us into generative modeling, because where is the mean and the standard deviation when you're dealing with contents on the web or images? Like how do I come up with some kind of mean or standard deviation from the images that you see on the top right? We cannot do that. So what we instead do is we hand it off to a neural network. And we say, hey, there's patterns probably. I mean, there's probably patterns here. We're training with this data, and the models themselves are coming up with patterns. And then they're able to spit out images for us and text for us. Patterns that a human could not determine on their own or could not find on their own. We have to have these algorithms in the middle, like in between the data and our output, because humans can't go into all of the photos that are on the internet and determine any kind of sense from that, any kind of statistical sense, like a mean or standard deviation. So all we're doing is guiding this neural network, and the neural network is just that middle part where it looks like a bunch of neurons connected between the images and the little earth that's meant to be a representation of Wikipedia. We're just guiding it with some very simple tasks, and if they master those tasks, then we say it has captured the distribution. So when we say it's the next word or next token prediction, the example here is just the dog chewed the bone because we leave that part blank. But if the model can learn what the most likely answer for that is and get it correct, then we can say it started to learn the patterns of language. And it's really exciting. This is a really exciting piece of this technology. So what can AI do? It can automate. So it can do really repetitive tasks. that require little or no intelligence. It can at least augment knowledge. It can replace humans in single tasks, and try to mimicking the human experience is a little bit more challenging for it now, but it does have some human expertise. For example, we can train a model that will detect cancer in certain radiology images, for example. And it does that very well. And so that would be an example of sort of displacing some human expertise. Although there's always, like, as I'll get to in a minute, you should always have a human in the loop. And then wisdom or discovery is something that is also part of what this type of AI can do, which is really exciting. So what we wish AI could do, there's hard and easy problems. So the easy problem, which is what we're dealing with mostly now, a scientist specifies a function that they want to optimize. We have a data and we have a solid problem. And that is where generative AI is really good at doing what it does. Hard problems are things like the fundamental barrier to automating science is conceptual. It's the formulation of the problem, not its solution. So that's truly the hard problem, or the problem. So now I'm going to talk a little bit about some blessings, or things that are really exciting advancements and things that we can do. So next week I'll be opening up ChatGPT. You'll be able to see how to use this, how to prompt some basic prompts to get what you're looking for, hopefully. So basic tasks is going to help you with so many things. It can create an image. It can help you brainstorm. It can help you create an outline. It can help you write or analyze an image. It can summarize papers, which could be incredibly helpful if you're in my field and you want to, write a lit review, and you can have, 10 or 15 papers summarized for you, and it saves a lot of time. It can interpret figures and correlate specific conclusions. This is an area, the data analysis area is still sort of up and coming, but getting better every day. And AI for science is a really good example here. So as we know, there was a chemistry Nobel Prize that went to the developers of AlphaFold, and they discovered that protein folding, or solved that protein folding problem. And this is, again, sort of like going to the dream of dreamers. The future of AI is that, or we hope, is that it will be able to be an autonomous researcher, or almost like a co-author with us, carrying out discovery on its own. This has also really spawned a new paradigm. So we have this AI-enabled scientific discovery. So it's going across, physical life, social, health, agriculture, many other sciences, advancing core AI principles and training a new generation of what's important to note is interdisciplinary scientists. So there's a movement to be more interdisciplinary because we need these human elements from all of the sciences so that we can create better problems together and then hopefully use AI to help us solve them. So there's a synergy between humans and artificial scientists. It's truly reshaping how we conduct research. Just some really cool things that are being worked on. Body on a chip. It's just this idea that you can put a chip in your body, and if you're just putting like any blood or anything over it, it sort of puts all of that data into a database, and then it can determine, are your kidneys functioning correctly? Is your heart functioning correctly? And you don't need a lot of invasive tests or surgery to figure these things out. If this chip works the way it's supposed to, it will detect anomalies in your body and then lead you to seek the appropriate care. Of course, we're not quite there yet, but it's something that's being thought about. Digital twins, just being able to mimic the human body so that you can see exactly how, like, you have your own like physical self, but the doctor has your digital twin, and they can sort of start diagnosing based on what they see on those images. This can be applied to many other things like industry, warehousing, all sorts of different ways that digital twins can be useful. Reframing education. This is something that we are constantly talking about here at Penn State. It's going to evolutionize essentially how we deliver content to our students, and how we can improve and innovate to make their learning experience even better. And this will stretch back all the way to elementary school children. Already, there's personalized learning and tutoring systems. One thing that's come up constantly in the class that I co-teach is that it's clear that elementary and high school teachers can use these tools to make personalized learning. And I'll show you a couple of examples that will become more clear to you in the following lectures, where you can see sort of how we can personalize the content that we're getting to a specific audience. And it makes it really helpful and useful to both the learner and the person who's trying to create the learning environment. Again, adaptive curricula. AI can analyze student data and adapt the curricula in real time, ensures the content remains relevant and tailored to the specific needs of the student. And that's really important. We're seeing a lot of students with disabilities, and this would really be helpful in those cases. However, as I mentioned before, we have to be careful that we're still making sure that our students and ourselves are thinking critically. We can't just rely on what's being shot out at us. And problem solving is so important. Adaptability is so important, and teamwork. All of these things are going to be really crucial in an AI-driven world. And of course, there's curses. So accountability. It's hard to decide who is going to be accountable when AI gets it wrong. And that is a really tricky question, one definitely that could take an entire lecture in and of itself. Just the sticky places of legality here, and where does the buck stop? How do we know what's responsible? Is it the user? Is it the person disseminating the content? Is it the AI itself? It's been an issue since social media and the internet, and it's one that is now basically a superpowered problem, accountability. Regulating AI. This is a really interesting technology because essentially, with past major technological innovation, we've had time to allow the basic science to accumulate to understand what was going on with this technology before it went out to the public. But that is not the case with AI. It was sort of let out the door, but we don't fully understand how and why it's working. And so the science is lacking. So regulating it is going to have to be really carefully done. Researchers still are unsure if these models are actually mimicking what we think of as artificial intelligence, or as our own intelligence, or is it an entirely different type of intelligence that's being exhibited by these generative AI models? We don't know. We like to believe, I think, because we know essentially how our lived experiences are, how we know basics of how our brain works. So we want to be able to say, paste that on to something that we've created. But the reality is we don't know if that's true or not. Reliability. As I mentioned in the bad earlier, there was a Korean man who was crushed to death. The incident occurred when the robotics company employee was inspecting the robot, and the robot failed to differentiate him as a human. So, there's some issues with reliability and quality control that really need to be accounted for. Data governance. This is also another issue. The United States has done a poor job of governing any data. But there's at least talk about dealing with privacy, et cetera, in this space. Although I'm not confident we'll see anything truly develop in that space. Then, of course, AI and job displacement. So you're already seeing a lot of movements by unions. I'm sure many of you saw the writers' strike in Hollywood. In part, that was driven by concerns that they would be replaced by artificial intelligence, and they wanted to make sure that they were not. Other industries, too, are contemplating this concern. And they're not wrong to be contemplating that. It will, in fact, probably have pretty dramatic impact on our workforce. But as previous revolutions have shown, it's likely to create more jobs than it destroys. But they're going to require, just like previous revolutions, different skill sets, different types of education, different education levels. So AI and job displacement, just to give you an idea of what people are thinking. Food preparation is one that they're thinking will be automated in the next several years. Teaching is at the bottom, which is interesting. Personal services, driving, although we've seen the promises of self-driving cars for quite some time, and yet they have failed to catch on at this point. But we'll see what the future holds. And interestingly, as I mentioned before, AI is writing over 25% of the code at Google, which really makes us wonder or has posed the question of what the future is going to look like for software engineers. The very people who are designing these programs are in danger of being replaced. And of course, there's issues of hallucination. I talked about the plagiarism issue. We have issues with student plagiarism. To be fair, we've always had issues with student plagiarism. We've always had issues of plagiarism and unethical behavior in the science field or research field as well. But it's easier to do now with generative AI. Hallucination is an interesting output of generative AI where it will, on occasion, make up something it could be completely wild, absolutely untrue. In part, there's a social desirability bias in these models where it wants to please you. It wants to give you the answer that it thinks that you want. So instead of saying, I don't know, it's much more likely to give you some answer that isn't true. And then if you push it and say, hey, I know that there's at least, I know that something's missing here. I know this isn't the correct answer. Then the model might say, oh, I'm sorry, I'll try again. But it won't originally do that because it's trying in its way to please. I will say that there are advancements in this area with reasoning in some of the newer models where they're trying to fix this hallucination issue and also be a little bit more hesitant to completely want to please. AI and bias. Bias sneaks in because, at the end of the day, the AI is trained on human-created data. So there's training data bias. All of the data that we've put on the internet necessarily over-includes certain information and under-includes certain information. So there's automatically a bias there. There's algorithmic biases because the people who are designing the algorithm have their own biases when they're assigning weights and training the models, and cognitive biases. And they're really challenging to fix too. So on here, you'll see there's an Inside Amazon Scrap secret AI recruiting tool that showed a bias against women. It was really hard to fix that problem. And so they just had to scrap the entire tool. Decoding the AI Penn. This is another issue that especially professors are really concerned about, and probably people in industry as well, that I think will lead to a lot of even consumer skepticism. It's really hard to tell what's generated by AI and what is human generated. And almost every day it gets harder and harder. So that's just a harm we have to really be prepared for. There is some talk to make things maybe watermarked so you know that it's generative AI. And we'll just have to see where this goes. But currently, if a student hands in a paper that they generated by AI, and let's imagine that they edited it a little bit, it might be really challenging. It would be really challenging for me to know that they did that. And of course, there's also some talk about AI, the output being a threat to itself. So if it's generating a bunch of junk and then learning on that junk, we go back to the training bias, where we have bias in the training data, and it's learning on that and producing junk itself. Okay, so we're in the home stretch. I'm going to leave you with some takeaways. So as far as the reject or embrace arguments, at least for myself, and I can't speak for all of my colleagues, but at least for myself, I definitely in the class that we teach to the undergrads, we really are encouraging them to embrace this technology, to use it as a type of co-intelligence. And there's 4 rules from the book Co-Intelligence by Ethan Malik that we sort of use to guide ourselves and really think about the usefulness and how we are going to be using this technology as it evolves with us. So the first of those rules is to always invite AI to the table. And I encourage our students, I encourage you to try to integrate AI into everything that you're doing. Have ChatGPT open, have Gemini open, have Claude or Copilot open, so that you're able to start playing with it and see how it can be integrated into whatever your daily activities happen to be. And these experiments, this is all very new. So almost everything you do, you could discover something that no one else has discovered yet. As far as like prompting and getting a particular response or a use case that people haven't discovered yet. All of this is so new. Just experimenting and finding out what's useful to you is just really important. Where are the frustrations with this technology? That might be a spot where you could fine-tune a model that's particularly useful to your particular use case. Or you can see how it might impact your job or your organization. Certainly, it could give you a potential edge if you're really up to date and using the technology. And through experimentation, we're hoping that you can become an expert on the edge of this frontier. So you're always inviting AI to the table. That's just be a given. If you're doing something, it should at least be open. You should be ready to employ it if needed. Always be the human in the loop. So AI needs to have, it works best, at least today, at least in today's environment with generative AI, it works best to have a human in the loop. There needs to be quality control. I mentioned that there's hallucinations, or you can get a response that is trying to please you but is incorrect. You need to be the person who is checking to make sure that in fact that information is correct. Let's imagine you're trying to make a deck for a client presentation. You can't just say, use like beautiful AI and say, make me a deck for this topic. It will make you a deck for this topic. But for example, I made a deck and I wanted it to give me the history of squirrels. And it created a really beautiful presentation. But some of the pictures were not of squirrels. And some of the information was also incorrect. So I had to go through a lot of the flow, making sure I had key takeaways and the length that I needed was right. But there were key pieces of expertise that I needed to add in. I had to be the human in the loop to make sure that that presentation was correct. And this is barring an unexpected leap in large language model capabilities. Every day there's hype about that, but it does not appear that we're close to that kind of leap at this point. So being that human is going to be really, really important. Treating AI like a person, but tell it what kind of person it is. This is really important. So the model itself has no personality. It has, no motive. But if you want it to speak to you kindly, like let's imagine you want it to interview you and you want it to give you constructive criticism, but you're feeling a little bit sensitive today, so you want to make sure that it's gentle in its comments. You could tell it how to interact with you. And that also comes into play when you're trying to create a lesson plan, which we'll get to in the coming lectures. Just where you'll say something like, I want you to talk about biochemistry, some portion of biochemistry, and I want you to make it explainable to a 5-year-old. The 5-year-old is the audience, and it will do that. It can change audiences and provide the content for each of those audiences, but you have to be the one in control. You have to be the strategy behind how it's going to act. And some examples I had here are, you are a comedian who, or you're an expert technical product marketer who, and allow it to act that way. And then the fourth rule is to assume that this is the worst AI you're ever going to use. And I say that because all of these limitations are likely transient. As we saw just as recently as 1989, it was hard for computers to even understand or take into account handwritten letters. Now we have the capability of learning from the entire internet, plus all of the photos and video content, and we're able to use that to generate, text, video, and photo content. Which is just incredible. And another thing that I know is that at the very beginning of our class last semester, we had students creating these images, and sometimes the images would require there to be some type of text. Like maybe you wanted a logo that had like 1996 Penn State or something. At the beginning of the semester, the text in those images was poor. Like it would be some jumbled something. It wouldn't necessarily resemble text. It might not even be text. Maybe it got part of it right, like it got a 6 in there, or the 1996, but it really messed up Penn State. As the semester wore on, that got better and better and better, and it's continuing to improve even today. And then, of course, this example I have here for you is an example of the same prompt that we're putting into the AI, which is a black and white picture of an otter in a hat. On the left, it was this like funky, hattish sort of otter type thing. But in 2023, that was in 2022. And in 2023, that same prompt yielded a really smart looking otter with a hat. Just to give you an example of how amazingly quickly this technology is improving. So the 4 rules of co-intelligence that will rule essentially or frame how we talk about using the technology in the coming lectures, always invite it to the table. So we'll be doing that. We'll be remembering to keep the human in the loop because that's really important with this technology. We are not at general AI yet. We are still dealing with task-driven artificial intelligence. We're going to treat AI like a person, but we're going to tell it who it is. We're going to tell it how to act because it itself does not know. And we're going to assume this is the worst AI that we will ever use and that it is constantly improving, which is true. I mean, we even saw in compute power recently, the DeepSeek announcement came out. And I was mentioning to you how expensive it was to train those models, in part because it requires so many chips and so much time and so much energy. What DeepSeek was able to do was reduce that amount of cost. And so that's a huge improvement in compute too. So there's really significant improvements in all pieces of this puzzle. The data, we're constantly collecting data, the algorithm, and the compute power. So that is the content that I have for you today. Looking forward to the next 2 weeks, we'll be doing more hands-on prompt engineering-based exercises. I wanted to note that today's lecture is brought to you in part from the Generative AI for All class that Dr. Madhavi from Computer Science and I are co-teaching. It's a general education requirement for our undergrads. And I'm excited to have you join me in the next 2 weeks for a basic overview of how to use the models. Thank you so much.